So we've even further trimmed down and added more steps in between. So this year for the camp, we had the circuit and we had them do the wiring of just this part. And even that part, there was some struggles with it because understanding like how the chips are oriented, understanding the different inputs for the gates and so forth was a bit challenging. So what we've done is we've come up with, or I should say Maddie has come up with, this worksheet which has the flow chart as to what the circuit represents. So you'll notice that our XOR number 4, this is now labeled as this top XOR gate in this diagram. So Winter has updated this. So this is AND number 4, and this is connected to the A0, B0, and so forth. So she's labeled this way. So there's these 5 like this, and then 5 like this. So this one is 5 volts, this one is ground. And then this is like I forgot what it is, A1, A0, B1, B0. And this is like S0, S1, S2, S3, something like that is the circuit that you're going to be working with. So your 9 volt that you're putting in, your battery, it's going to this regulator, and then it's going to output 5 volts. And the 5 volts that you get from this printed circuit board chip that you plug into your protoboard, you then are going to connect it. So you're going to have soldered pins on these 5 connections, and which we did yesterday, and you're going to plug that soldered connection, the pins, now into your protoboard. We separated the pins exactly so that they fit across the gap in the protoboard, and then you'll take the 5 volt, so there's these other outputs, the other parts of the 5 volt that you've plugged in. These are all connected in the protoboard. You need to create a jumper wire that's going to go to the positive rail. And for ground, you need a jumper wire that's going to connect to your protoboard that's going to go to the negative rail. And then your chip, which is sitting should have brought the document camera. So the chip that you have here, you're going to have, for example, your XOR, and you need to power this. So in order to power it, you now need a jumper wire to go from the positive to the row that's connected to pin number 14, and you need a jumper wire that's going to go from the ground to pin number 7. So that's how you power your logic gates. So the 9 volts on the circuit that you soldered yesterday, there's a regulator inside. So it's going to convert it down from 9 to 5. So now that it's 5 volts, you have that as one of your pins on what you've soldered. So you have a pin that has 5 volts and you have a pin that has ground up to the rail. Yeah, so you're going to plug in these pins. This pin is going to connect to a column, and you're going to have a jumper that you connect from the column up to your positive rail to power up the positive rail. So in this worksheet, for example, it says orientation. So your printed circuit board, we want to plug in the printed circuit board in such a way that this 5 volts is going to sit in position 9F. So column number 9, row F. So if you plug it in that way, then there's a unique orientation of your printed circuit board, and then you can fill out the rest of the diagram relative to that. Okay, so pin 14 is going to be going into column 16, row F. So that way you have your XORs in a specific spot. Similarly with the AND and the OR, these quad chips, you're going to plug these into specific spots. So this is plugging into 27F, and this one's plugging into 37F. So now, in order for us to realize this diagram, each quad gate has 4 gates inside. So I talked about you need to power it, so 5 volts need to go into pin 14, ground needs to go into pin 7. This is your first XOR gate. So in the updated version of the book, there's going to be a, I'll say XOR number 1. So this is your XOR gate number 1. This is XOR gate number 2, XOR gate 3, XOR gate 4. Okay? So it goes counterclockwise according to this notation. So for example, we have XOR gate number 4. The inputs to that are A0 and B0. So XOR gate number 4 is this one. So what we want to do is we want to connect A0 A0 apparently is going to be, so if this is 9F, 8, 7, 6, 5. Okay, A0, so I labeled it correctly. A0 is sitting in 6, and the U means it's on the upper half. So the numbering system is each column has a number. Unfortunately, you can't, and if you're above, these 5 pins are connected, so it doesn't matter which pin you plug in the protoboard. Remember, your protoboard, you have 5 things that are all connected to each other on one side of the rail, and you have 5 things connected on the other side of the rail, or the gap rather. So there's a gap in between. The gap is designed to be able to plug in these 14 pin elements so that you have different pins connected to the top and to the bottom. So we're going to call this the upper half and this the lower half on your printed, or on your protoboard, so your white protoboards. You have the upper half and the lower half. So the numbering notation that we have, A0 is in column 6. It's on the upper half. So we have 6U. This is where this pin is currently plugged in. So if you plug in your printed circuit board to the protoboard such that the 5 volt is at 9F, then A0 will be at pin 6 in column number 6. Does that make sense? Ask questions. You okay? You okay? Okay. So this is going to go into column number 6. Now, this is the circuit diagram that's equivalent to what you did in SimSir. So in SimSir, you have this picture. So right now we're working on the wiring connection from here to here. We want to orient this simulation, we want to understand the simulation according to this diagram. So we have XOR number 4. It's going to connect A0 and B0, and the output is going to S0. So we want to write in our worksheet what locations is the start and the end of each one of these wires. And the reason that we do this is a lot of times when students start wiring stuff together, they get really confused as to what they've done, what needs to go where, and so forth. So we're going to have it written out first so that the students see how to translate what they've simulated to something that looks more standard, and then they're going to translate this into what's on the protoboard. So we're working on this connection. So the left side is A0. A0 is in 6U. So that's the 6U on the left side of A0. The right side is XOR number 4. XOR number 4 we have is this pin, so it's these 3 pins. So XOR number 4 are these 3 pins. This pin for XOR, this is in pin 16F. So this is going to be 15F. So 15F, or sorry, I'm going up. This is, okay, so this on the protoboard is 16F. This would be 17, 18, 19. This is the gap where we're plugging in our integrated circuits. Above the gap is upper. So this position, these 5 columns, or these 5 elements in this column, this is in column number 16. This is in column number 17, column number 18, column number 19. So the XOR 4, it says 17, 18, 19U, meaning that it's using column number 17, column 18, and column 19. So the inputs are 17 and 18. The output is column 19. Okay. So in order for us to make this one-wire connection, we're going to write on the left side, it plugs into A0, which is 6 in the upper. On the right side, it's 17 in the upper. So we've connected to this pin. So the part where it says 6U, and it's going to 17U, this side of the pin, this was our A0. This side of the pin is the input to XOR gate number 4. That happens to be pin number 13 on the XOR gate. Okay. So that's one wire. So we've connected A0 to XOR number 4. Okay, so now I'm going to ask the class, if we're going to go from B0 to XOR number 4, the left side of B0 is where? So we have 6U, and then we're going to have 7U, 8U. So the left side is going to be 8U. So we have B0 now. The left side is 8U. The right side is going to be going to XOR number 4, which is this particular pin. This was 16, 17, 18, right? So it's going to connect to 18U. Okay, does that make sense? Okay, so now your activity, the activity I guess that everyone gets to do tonight, and you get to talk with your lab or your partners, is to fill out these other boxes. So we've done the top 2 boxes for you. So for example, we've done the connection between A0 and B0 to XOR number 4. We've done the connection between A1 and B1 to XOR number 1. So we've done these 2. We've labeled which pins these are going to. We want you to do the connection for AND number 4. We want you to do the connection for XOR number 2, XOR number or number 1, and number 2, and so forth. Save it so that you know the wiring of what you're trying to achieve. This diagram is identical to this diagram.